Hello, I'm Enzo Hain, and together with Jessica Chapla, Joshua Christo, and Stephanie Tomaro, we worked with Mitsubishi Electric Power Products Incorporated for our senior design project. Just a little background on Mitsubishi. Mitsubishi was first founded in 1870 by Yataro Iwasaki. It started as a shipping company, but eventually grew into other fields such as mining, business, automobiles, and other industries. Mitsubishi Electric Power Products Incorporated was founded in 1921, and they are located in Warrendale, Pennsylvania. They produce two types of circuit breakers: gas circuit breakers and vacuum circuit breakers. Mitsubishi management has decided to roll out facility layout improvement initiatives from previous catalyst connection consulting projects to their gas circuit breaker production process. Their goal is to that without reduced product quality or introduce additional personnel, they would like to reduce overall labor hours, improve product flow, and increase throughput via facility layout redesign. For our methods of analysis, the team first took process observations and time studies. These were extremely important to the project due to the fact that it takes over 46 labor hours to produce one circuit breaker. So from there, we used our time studies to calculate our standard times and true labor hours required for the process. And we eventually used that to compare it to MEPPI standards, which served as our efficiency study. Here's an example of the time study sheet where we essentially broke down a larger process into its elementary steps, its number of technicians required per step, its value added versus non-value added but necessary work content, and the cycle times and other times associated with the process step. Here's a snapshot of our efficiency study. As you can see, we have some historical data from MEPPI based on process steps, and we use theirs to compare it to our experimental times that we took for each process step. Over to the right is a little table of the standard labor hours required for a breaker. Now you can see MEPPI has their 2 times, and we have our 2 times.
The gas circuit breaker production process begins with the preparation of the tanks as well as the assembly and installation of the interrupters, the components of the breaker that halt power transmission in the event of a fault. The tanks are cleaned while the interrupters are assembled in a separate subassembly work cell. When the interrupters are finished and a set of tanks has been cleaned, 3 interrupters are installed into the interiors of the 3 tanks. Afterwards, assembly begins on the 6 bushings, and once complete, the technician installs 2 bushings into each of the 3 tanks using the overhead crane. 6 current transformers or BCTs are installed onto the tanks. At this point, the tanks are installed on the main breaker frame, again using the crane. If heaters have been requested by the customer, then they are also installed at this step. Initial wiring and preparation is conducted by the technician on the breaker cabinet, and the cabinet is then installed onto the breaker frame using the overhead crane. The frame is then moved to the main work cell for final wiring of the electrical connections and begins a lengthy testing process to guarantee product functionality. The breaker then undergoes final inspection by Mitsubishi quality personnel. The assembly process is internally documented through a series of steps based on the breaker bill of materials. This table indicates MEPPI's current assembly process as previously described. We propose implementation of a new BOM breakdown for process documentation to more accurately reflect our changes to the shop floor. This table displays our proposed BOM breakdown for the assembly process. Steps are now grouped into 4 categories based on the stage of the process. Steps in the 100s category include subassembly procedures. Steps in the 200s category include mounting of components onto the main tank frame. Steps in the 300s category include wiring procedures, and 400s include final testing and shipping preparation.
The original facility layout of MEPPI features 12 cells that make up the GCB line. Besides the last 4 cells marked wiring area and the bushing assembly cell, assembly of a gas circuit breaker would occur in any other cell. Since a technician follows the GCB through assembly, there are no other designated work cells besides the ones mentioned before. The current layout allows for multiple technicians to be on multiple GCBs in different steps of the assembly. Based on our efficiency analysis, our proposed alternative layout is separated based on the new BOM breakdown featured previously. There is now an assigned department for all assemblies housing tank prep, interrupter assembly and install, and bushing assembly and install. The proposed layout has 1 cell dedicated to cabinet to tank install. There is also a backup cabinet to panel installation area. Lastly, the 4 wiring cells stayed in their locations based on the constraint of in-cell testing equipment. As described earlier, we broke down the work steps into value-added, non-value-added, and non-value-added but necessary steps. After making our suggestions, we determined that the percentage of time that is value-added goes up in work step 120, 130, and 140. Similarly, the non-value percentages decrease. As a deliverable, we are suggesting new standards to MEPPI. We are suggesting that for their 32 kilovolt breakers that they allot about 39 hours, and for their 40 kilovolt breakers that they expect it to take about 37.5 hours. As a result of our project, we are reducing the travel distance from 144 feet to 72 feet, which is a 50% reduction. With improvements, the labor hours will decrease from 46.8 hours per breaker to 38 hours per breaker, which is a 26% decrease. MEPPI will be able to achieve a throughput of 40 breakers per month rather than the 32 that they plan for currently. With the changes made to the layout, MEPPI will have 950 square feet of extra space for storage and prototype builds. Overall, we will suggest changing the layout to have a main subassembly cell, 1 tank mounting cell, and then 4 wiring cells. We will work with MEPPI to recommend a suggested number of workers per cell. To minimize the movement of the workers, point-of-use storage should be implemented for all tools and raw materials. Lastly, we suggest that MEPPI changes their standard from 5.2 useful hours per day to 6 useful hours per day. On behalf of our senior design team, we would like to thank Eric McDonald of Catalyst Connection for his input during this project. We would like to thank the members of MEPPI for answering our questions and being so helpful this semester. We would also like to thank Dr. Sakri for her input on the direction of the project through the semester. Additionally, we would like to thank Dr. Haight for his suggestions on ergonomic efficiency. We hope you enjoyed our presentation. Thank you.